Welcome back, everybody. This is going to be part 4 of 5 in my lecture series on functions. In this video, we're going to look at how symmetry affects functions and how we can identify it without even graphing. Let's get started. Suppose we're looking at some point x comma y on the graph of f. We say that f has symmetry over the y-axis if negative x comma y is also on the graph. Similarly, we would say it has symmetry over the x-axis if x comma negative y is also on the graph, and it has symmetry across the origin if negative x negative y is on the graph. Once again, this is an example of where the written definitions don't do a great job of helping you visualize what's going on here. So let's draw some pictures. Let's start with symmetry over the y-axis. If I've got some point on my graph, let's say I've got 1, comma, negative 2. Supposedly, negative 1. I don't know why I wrote that. Supposedly, for it to have symmetry over the y-axis, negative 1, comma 2 should show up as well. And this kind of makes sense because it makes the y-axis look like a mirror. Similarly, if I had, let's say, 1, comma, negative 1, that's not 1, negative 1, 2, comma, negative 1. I should also have negative 2, comma, negative 1. So one potential drawing for this function would be something like this. And notice that this looks like I could fold it over the y-axis and both sides would line up. That's why we say it has symmetry over the y-axis. You can imagine kind of the same thing is going to happen with the x-axis. If I have the point negative 2, 2, then supposedly negative 2, negative 2 should be on the graph according to my definition. Same thing, if I had 0, comma 1, then 0, comma negative 1 should show up on my graph as well. So a function like this, or a relation like this, because this would not be a function, has symmetry over the x-axis. Similarly, over the origin would be combining the two. So if I've got, let's say, negative 1, 1 on my graph, then flipping both signs, 1, negative 1, should also be on the graph. And so something like this has symmetry over the origin, where it looks like if we folded it over the x and then y-axis, it would line up together. But we can actually determine some of this without ever graphing it, because even functions, an even function meaning if I plug in the opposite input, I get the same output. Notice that matches up with symmetry over the y-axis. When I plug in the opposite of x, I get the same output, y. So we call functions like this first one here even. And I can verify that without ever sketching the graph. So notice here I have f of x equals x squared plus x to the fourth minus 2, and I'm asking you to show me that it's even. The way I do that is I plug in the opposite. I plug in the opposite function value. And what I'm looking for is whether or not I get the same thing. Well, I know that when I multiply negative x by itself, I get positive x squared. And when I multiply negative x by itself 4 times, I get positive x to the fourth. Minus 2 doesn't do anything. Notice I got back the exact same thing. So this is even. We call odd functions like this third one that have symmetry over the origin. And the odd functions say, if I plug in the opposite input, I should get the opposite output. Let's see how that lines up with their definition. If I plug in the opposite of x, I should get back the opposite of y. So how would I show a function as odd? Well, the same way I would show a function as even. I would take f of negative x and see what happens. And here I'll use some color there. Here, I would get negative x cubed minus 7 times negative x. I know if I take negative x and multiply it by itself 3 times, I get back negative x cubed. And negative 7 times negative x would be plus 7x. Notice I got back the opposite of the original function. It might be a little bit easier to see if I factor out that negative sign. So this is an odd function. In this video, we looked at how to determine whether functions have symmetry and what that means. We also looked at even and odd functions and how to tell whether a function is even or odd just by looking at it. In the next video, we're going to take a look at a special kind of functions called piecewise defined functions. Catch y'all in the next one.